packet structure, DHCP messages, leases of IP addresses to clients, and DDNS. Dynamic Host Configuration Protocol, or DHCP, automates the process of configuring new and existing devices on IP networks. An example of this might be a new or relocated VoIP phone. Hello, and welcome to this InfoBlox DNS DHCP Fundamentals webinar. My name is Michael Lansky, and I'll be your presenter. This is Module 5, addressing DHCP basics, pool management, and dynamic DNS. An auto run of this presentation takes about 9 minutes. Let's quickly review the Table of Contents page before we begin. This slide is your Table of Contents. During the presentation, you can click on the TOC link to return here at any time. Each bullet item above is a link to that topic, allowing you to navigate to the presentation as you see fit. Some pages contain drill-down links that provide you with extra information. Clicking back will return you to where you left off. If you allow the presentation to auto-run, you will see each of the topics in the order shown. This presentation discusses the introductory issues of DHCP, including the IP packet structure, DHCP messages, leases of IP addresses to clients, and DDNS. The Dynamic Host Configuration Protocol, or DHCP, automates the process of configuring new and existing devices on IP networks. An example of this might be a new or relocated VoIP phone. When powered up, the phone requests information from the DHCP server. The server replies with what information it can, and then, optionally, adds records to the DNS server and/or logs the event. DHCP is built on top of the older BootP protocol. There are two primary differences between DHCP and BootP. First, DHCP includes the concept of a lease time, through which the clients can be assigned an address for a finite lease, allowing the client to renew the address as long as it still needs it, but also allowing the address to return to the available pool when it is no longer needed, so it can be reassigned to another client. Second, DHCP provides a mechanism for clients to acquire additional configuration parameters that it may need in order to operate. DHCP introduces a small change in terminology intended to clarify the meaning of one of the fields. What was the vendor extensions field in BootP has been renamed the options field in DHCP. Similarly, the tagged data items that were used inside the BootP vendor extensions field, which were formerly referred to as vendor extensions, are now called options. Using these options, the DHCP server can both learn information from the client as well as give information to the client that it has been requested to do. There are 4 major types of conversations performed between the DHCP server and clients. They are referred to as conversations because multiple messages must pass back and forth for each task to be completed. The first conversation type is a new lease, which, as you would expect, is how a device obtains a new IP address. The second conversation is a renewal. This conversation is invoked approximately halfway through the lifespan of the lease and is used to extend the lease period so that the client may hold on to its current IP address. Occasionally, a client knows it no longer needs its IP address and can use the third conversation type, release, to give the address back to the server's available address pool. The fourth conversation type is inform. It is used by a DHCP client that already has an IP address but needs to obtain additional information that may not have been asked for during the new lease or renew. In the next few slides, we will look into the details of how each conversation works. On this slide, we'll discuss the steps involved in a device getting a new lease and dissect the IP packet. In this first diagram, the client broadcasts a discover message to all DHCP servers requesting an address. The IP packet format is as follows. The IP header at the top, showing a source IP address of 0.0.0.0, as the client does not yet have an address of its own. It also does not know the IP address of the DHCP server, so the destination address is set to 255.255.255.255. The UDP header is next. We can see that the source port of UDP 68 is used by the client, which then gets sent to UDP port 67 on the server. In the bootp header, we can see that the boot request flag is set and all the IP addresses are zeroed out. We are asking for a new address, so we would have no information to place here. And last but not least, we see the options section we may have for the DHCP server, plus a list of options that we are requesting from the server. And now back to our client and DHCP server diagram. The replies to Discover messages are called offers, and they contain the proposed IP address, terms of the lease, and other parameters that may be relevant to the device type. Although, from an IP perspective, broadcasts are used during new leases, unicast frames to the client is the preferred method of delivery. For example, if using Ethernet, the Ethernet MAC address of the client, which we know from the Discover packet, would be used to the destination of the offer. Since clients can receive multiple offers, how do they decide which to accept? It's simple. The client chooses the first offer it receives and sends a request message requesting the IP address of the offer. On the DHCP server side, the following process is used to select an address to send back in an offer message. First, if there is a fixed or static IP address reserved for the client, assign it. Second, check the MAC prefix table for a match or any other filtered pools that may exist and choose from the assigned pool. Third, check to see if we already have a known assignment for the client and assign it. Finally, draw an address from an appropriate pool and assign it. The amount of time a device can use the lease is not endless. bootp did not use the concept of a lease time, but DHCP only lends them out for configurable periods of time. In the options sections of the DHCP payload, there are 3 timers that controls how long an address can be used before renewal should be attempted, how long to keep trying before finding a new server to renew the same address, and how long until the client simply has to start over and start looking for a new address. Renewal of a lease is much quicker. The client sends a unicast request message to the server, and the server returns an ACK message. The timer T1 drives the renewal process. Other servers are not involved unless the original lease grantor doesn't respond. If the original DHCP server does not respond to the unicast request, the client will switch to using broadcast request messages, hopefully finding another server that will respond, granting the client continued use of the same address. If the client cannot renew its lease, it will fall back to getting a new lease starting with a Discover packet. Although many devices simply move on and leave their lease to expire, a client can return an address to the available pool with the DHCP release message. Dynamic DNS, or DDNS, allows the DHCP server to change DNS records on behalf of the clients when address changes take place. This animation shows how a client has sent a request for an IP address that was offered by the server. Everything looks good, so the server acts the message, granting the lease, and then notifies the DNS server of the results by registering the name and IP address into the DNS server. As we saw in an earlier slide, other logging can also occur to record the events that took place. This completes this DNS DHCP Fundamentals webinar. We thank you for taking the time and invite you to review all the other webinars in this series.